You're welcome.
Hello, guys. Yeah. All right. Okay. Yeah. Yeah. Okay. Okay. I think we're good. Cool. With this, we'll not be able to get feedback. Cool. That's all. Yes, yes, yes. No, I get it.
Yeah, can somebody join? It's once it's not starts.
We could just go on if I show that. All right. So share my screen. Awesome. So, greeting guys. So we're talking about account abstraction in relation to the Ethereum blockchain. Okay, I think that's big enough. So from the data we have currently, not everybody here is a blockchain developer. So would go a little bit rudimentary. So we will know how to rush. We still have some online sessions. So we'll take it step by step. The blockchain accounts, why do we need accounts? Okay, why do we need to abstract accounts from keys? Then build an account. That's a smart contract account. That's really the meat of what we aim to do. So that's going to be the meeting agenda. So see, we get tired, we will just stop by the way. The rest will just continue on online. Though I've written an article about this session and I've written the code for the smart contract wallet. So our geeky friends here can just go ahead of the class and go on and learn faster. So I'll be making use of a scala to illustrate some things as we proceed. So first we are dealing with the blockchain, and the accounts we are talking about is on the blockchain. So just a brief refresher on what the blockchain is. So the blockchain simply is just networks of plenty computers, multiple computers in different geographical regions, all connected together, sharing states, right, sharing states, and all in agreement of what that state is. So just imagine like a bank distributed in many countries. And when I say I own $10,000, if I ask any of this bank, they can ascertain that I have $10,000. So that can be like a good mind picture of what the blockchain is. So the account now is how does the blockchain know me? How does the blockchain authorize that, yes, I made this request to transfer this money to this foundation? So that is what an account is in general. So now we like have a picture of what we are dealing with. So we now like dive deeper on uh, what this account is, much more technical level. So an example of let me not call it an account. This is a wallet. An example of an account is this boy here, this OX something. So let's go to an explorer. Let's go to Mumbai. So an example of an account is this. This is an account. So this is how an account in the blockchain look like. So just imagine this like your account number for your normal bank. So with this account now, I can know the things I've done before, the amount of money I own, places I've interacted with in history. I can do my accounting for the month. So that's just basically what this account is. So when you see this OX stuff, just know that, okay, this is what the blockchain sees as an account number. And how do we control this account? So we have tools like MetaMask. So with this MetaMask, this is where your accounts live. There are other wallets. Well, let's talk about MetaMask. It's one of the most popular. So this is where your account lives, and this is where you interact with it. So should I want to send in some testnet ether to someone who wants it, I'll just come in here, then I'll look for this person's account too. Or I'll ask this person, like if I want to send you money, I'll tell you, give me your account number. I place it in my app and I send you. So happens here. If I want to send you something, give me your address. I place it into my wallet and I send you this token. And that's that on the lower level or on a little bit technical level. This is what an account is. So now for me to do anything, I need to have gas. So we'll go a little bit deeper now on what gas is. So see all this system of computers, people are running actual computers, consuming electricity, water for cooling, land space, and many other things that cost money. So they won't just be running all these things for free. So they need you to pay them some money for running these things. Just like your bank, they are not just handling your financial obligations for free. You pay bank charges, you pay interest on loans and all those stuff for them to survive. So does the blockchain also. So gas is just more like you want to do something on the blockchain. This is how much compute intensity this is going to cost. So you pay this amount of money. So if you want to transfer, let's go to Ether scan. So currently now, if you want to transfer Ether from one person to another person, it's going to cost you. Come on, boy. This guy is not scaling. All right, I think you can see that. So it's going to cost you 29 GUI. Don't think about the GUI, don't think about the units. Just look at this is what's more interesting to us, the dollar value. So if I want to send you 10 Ether, it's going to cost me $1.52. If I want to send you 1,000 Ether, it's still going to cost me $1.52. So a transfer operation just takes a very, very small compute intensity to happen. So that's why it's that cheap. So other things are not so cheap. So that is it for gas. So gas is just what we pay to the network. Please process my transaction. So yep, that's it for the introduction to blockchain and transaction. So let's talk about this transaction life cycle. What happens in the blockchain when I send a transaction that I want to send this money to my mom. This is my mom's address. So how does that transaction move from leaving my wallet to getting to the blockchain, executing, and change states, and my mom suddenly has this $1,000. So first of all, let's look at what a transaction look like. What is the properties of a transaction? So we would see that here. Yep. So this is how the transaction look like. There is a from. So who is initiating this transaction? That's me. So that's going to be my own address. All right. Okay. So there's a from, that the person initiating this transaction. There is a to. Who am I sending this transaction to? So if it's just a transfer, that means it's the recipient's address, account number that is going to be here. So now there is something called a gas limit. So how much am I willing to spend on this transaction? So if you remember that GUI we saw earlier, so that's the unit for gas. Later on, we'll dive into that. So I'm willing to spend 21,000 GUI. So it's a standard. Every transfer takes this amount of gas, and the equivalent in dollar currently is $1.52. So yes, technically, that if you don't have enough balance to foot that bill, it will not go through. No, it's not stalled. So it changes with time on demand. So the more people want to make transfers, the more people want to interact with the blockchain, demand goes up, the higher the price. So that's
Send it now. I mean, what maybe you don't want to transact.
Yeah.
I mean, GUI is lower than the standard.
Yeah.
It's still go.
Yes, it will still go. It's still go. It's still go. So I don't want you to see. I want you to see it like this. So the cost is 21,000 GUI, but GUI could have different prices at different times. So your 21,000 GUI can worth $2 tomorrow when on Monday morning when people want to transact so much. On Sunday night or Saturday night, no much transaction. Your GUI can just worth $1 or some cents. So that's it for that. So max fee per gas. So this is still gas related. So there is an EIP they released, EIP 1559 or so. It just tried to before that EIP. Okay, EIP means Ethereum improvement proposal. So it's just Ethereum is the blockchain we pride ourselves with open source. So anybody can come in. This is not right. We can do this better. Make a proposal. People discuss about it. Engineers vote and build on it, and we test it out on the test net. Is on the live blockchain. So that is for that. So there was an EIP to regulate how gas spikes. So when CryptoPunks and the early NFTs came in, yeah, Cookheads and Dugdu and all those guys. So once the demand spiked so much, the gas is so high. So it's not linear, it's kind of exponential. So they brought in this proposal so they can kind of moderate the gas. So the gas of the next block, the gas you need to pay for to add your transaction to the next block. Because the blockchain is just block, all chained together. I can prove that all these blocks are in part of this history of transactions. So to put your transaction in the next block, you instead of just because the demand is so high, pay high gas fee, there's going to be a factor of the previous block, then the future block, that the block to be created now before the gas you pay is calculated. So that's kind of brought in, if you look at the curve this time around, it's not just exponential, it's now a bit linear. So that's for that. So then the nonce. So the nonce is more like how this transaction you're trying to make is what's the number of this transaction you've made on this chain. So my nonce initially is 0 because I've not done anything on this chain. So if I make a transfer today, and I come back in the afternoon to make another transfer, my nonce would be 1. Just increments as you do transfers. Then the value is how much do you want to send. So the value that's here should be 1 Ether, I guess. So the value is just how much Ether do you want this transaction to go with? How much native currency, that's the Ethereum token, do you want this transaction to go with? So Ether is the way cents is 2 decimal. That's $1.00. That means the last one in that zero. Okay, let's say 1.01. So that one is cents. So that we can call a dollar a 2 decimal denominational currency. So that applies in Ethereum also, but this time around Ethereum is 18 decimals. So that's once you divide that by 10 raised by 18, you just get 1. That means I want to send 1 Ethereum. So that's for a transaction. This is how a transaction look like. So now let's talk about what happens when you send a transaction. What even happened before the transaction is sent? So we'll open up MetaMask now. So let me just get any address that can just gift some tokens for this demo. Okay, this is looking beautiful. Let's use this guy. So let's say this is my mom's address now. It's month end. I want to send mom some money. So I'll just come to my MetaMask. I have gas already, so I can process this transaction. So I come and press send. I place in mom's account number here, then the amount of okay, let me not be too generous. So the amount of token I want to transfer. So this is how much I want to transfer. Then you see this little thing here. This cannot expand above this. Yeah. So you see this, I don't know if you could see that, but you can see this little thing here. It says 0.00005 to 49. That is the amount, that's the current amount of gas that I need for this transaction to go through. So if I don't have this amount, my transaction will not go through. So that is that's for that. So now no, it doesn't. It doesn't. So nonce changes only when the transaction has been added to the block. So after this right now, I can just press next. Then I just need to confirm. You just give me like, no, when you put an account number, I show you this full transaction that's going to happen. So you be sure you actually want to do this. So I'll look at it. Yes, this is what I want to do. Then I confirm. So at the moment I hit this confirm button, or before I hit the confirm, let me tell you what will happen when I hit the transfer button, the confirm button. So when I hit this button, it's going to take this transaction. Okay, this is going to close if I try to use it.
Use just click on the last, click on the expand button, click on the transaction. Then you can use that large, totally.
Yeah. Well, I'll have to go back to do that now.
Just click on this. Okay,
yes, I'll have to go back to do that. Or let me just dash this person this money first. Expand view. All right. So yeah. So this is how this transaction will look like now. So ideally, this will be my address. This would be mom's address. This, I'm not specifying this because it's constant, and you usually will not specify this unless you need to. The blockchain automatically calculates it for you, or the wallet will automatically calculate it for you, then placing a value there for you. So all this the same, but this value you have to put it in yourself. You will not want anybody to calculate how much you want to send to somebody. It's my money. So I'll put in this. So, but in my case now, it's 0.0 something something, not this at the moment. So we can now go through that flow again. 0.001. Next. Then when I hit confirm, so what happens is, I think I missed a step when talking about this wallet. So there's a notion of public key, private key. And you get this public key and private key with something you call a mnemonic. So just those 12 words that they will shout, don't show this to anybody, don't give this to anybody, don't transfer it on the network, just keep it safe locally. So with that, now you get a private key, you get a public key. So now for you to push this transaction, you need to sign that, yes, me that owns this address, this from address, authorized this transaction to go to the network. So when you sign that, that's when you hit the confirm, that's what happens. It signs this, just like you have a check. You put your signature. When the check gets to the bank, they can process that because they recognize that signature and can prove it's you. So that's what happens. So when I hit this, I sign it. So the transaction is sent to the blockchain. You see it's pending. So once it gets to the blockchain, I let's say block mined, it's confirmed, and I'm deducted some amount of money. Yeah, it's quite small, so you won't see the change. So that is that for this transaction from my wallet perspective. So now let's go to the blockchain perspective. What happens? So first of all, how did this leave my wallet? How did this transaction, this structure, this object, this from to gas, how did it leave my wallet to the blockchain? So there are these guys, they call them RPC providers. So they are inferior alchemy, or you can just run up your own. So the idea thing is you just send this to one member of this blockchain node. So one member of these plenty computers connected together. And this one member gets it, gossip it to everybody. Everybody knows, okay, yeah, Uche wants to do this. And once everybody gets it, they process it, keep it. And then once the mining or the consensus algorithm for that blockchain happens, don't think about this big words. We'll talk about them later. Then everybody agrees, okay, yes, Uchi has this amount of balance. He can transfer this. And Mr. whatever they choose to push this to the blockchain, then pushes, everybody acknowledge, okay, yes, Uchi have done this and it was successful. And I see confirm on my MetaMask. So I think that's enough for transaction lifecycle. So I push this thing is being pushed to the blockchain. So anybody of those nodes takes this and gossip it. Everybody hears this. A block is to be created, add it to a block. So okay, the place where the transaction is waiting before it's going to be added is called a mempool. Just for context, we can just have that. So once it's added to the block is mined. That means my transaction has been confirmed. So that is it for accounts. That's the transaction lifecycle of a normal account. So we will not have so much time to dive into this blog. To read this blog are long in this talk. Yes. I'll share this. So well, the important parts why I highlighted you should go to the blog is to just understand why this account is working fine already. I can send money, I can do business, I can receive money. It's working fine. So why do we need to abstract this account? Why is there account abstraction? So so just a very, very blunt introduction to account abstraction. So you see that this account in my MetaMask OX5C, something, it came from my private key. It was generated from my private key. So in other words, I can say my key is my account. So or something came out from my key that is my account. So my key and my account are tightly bounded together. So for me to do anything on that account, my key also must be in sync to do anything in that account. So, but that poses some kind of challenges. For instance, gas fee. So we are trying to unbank the global financial system to go a little bit distributed and let there be no borders in the financial system. So, but to do this, we cannot just walk up to a banker that have been in the banking sector for 20 years and tell them, install MetaMask, get gas fee before they can receive money. They don't even know what's gas. So why bring in so much complexity when you need to onboard these persons to your side of conviction? So that's one of the problems account abstraction is coming to solve. So with account abstraction now, it differentiates these two entities. That's your account and your key. So now this account will then live on the blockchain. Then for you to do anything on that account, to send money, to make a subscription, to pay to execute your payroll, all those actions that you intend to do will then be authorized by a key. So the account is no longer the key is no longer the account. They are now two different things. But before this does anything, it must get an acknowledgement from the key that yes, go on, send this money. Yes, go on, execute this payroll. So that is what account abstraction is trying to bring into the table. So we should just quickly explore some other benefits of account abstraction. Okay. All right, so here are a few benefits of account abstraction. First, easier onboarding of new users. We've talked about that. Improved security. So if you are conversant or if you listen to the news about quantum computing, you see that our current cryptographic primitives could be broken in minutes, and that's not bad. So it means you can, from my password hash, you can get out my password in minutes. It means you can forge a signature for an Ethereum blockchain transaction. That means you can impose or impersonate me and steal my funds if you have access to that compute power. So because of our current cryptographic primitives are not quantum resistant, so that would pose a problem in the future. Should IBM finish building this? Should Google finish building this? And it gets to the wrong hands, that's chaos. And blockchain, we want to stay for the next 10 to 15 generations. So we have to be flexible to switch cryptographic primitives and easily, and not just get wiped away by the breeze of super powerful computers. So account abstraction now is now going to give you the power to make your key quantum proof. So you don't need to no, currently with the implementation I've just let you know, the key is actually just still your private key that you already get used to. So this is just an elliptic curve, maybe SP 520 or whatever curve they choose to do. So, but when with account abstraction now, the key is not just strict, go this way. When you are building the smart account, you can choose, okay, I don't want to use this curve for authorizing stuff to happen in my account. Make use of this stuff. This is how I want my key to look like. This is how I want my authorization function to look like. And everything's going to work fine. They are not just bounded to something that they chose to use in 2015 that could be outdated in 2030. So that is one for that. So the other improvement is programmability. So now, since your account is not just a key, it's a smart contract. So you can program certain functionality that you are used to on the Ethereum world. So you can now program a Netflix subscription on your account. By the end of this month, and this is also timestamp, should these guys come to take out 10 cents or $2 for my monthly subscription, allow them. So all those programmable stuff that we can do on Web2, we can now achieve them, though with some constraints, because it's still Solidity that you used to write it. So we can now do like multi-sigs and natively to an account. So the other benefit I really like is inheritance. So let me say I am still this blockchain entity that still maybe 70, 80. And then I'm planning now, okay, this is how I want to share my wealth to my children, to my relatives, to philanthropy, charity, and all those stuff. So, but for me to do that, I will have to now pull all this money out of cryptocurrencies, keep them in the bank or maybe landing properties. Then a lawyer comes in, and that's it. But why can't we just do all this on chain? And but it's problematic if you want to do it on chain. That means my private key, that stuff that we should not share, I'll have to share it. And then anybody that have it can say they are me or that person is me. And everything is gone, so there's nothing to share again. So with smart contract accounts now, we can now do something we call a dead man lock right in your account. So you can just say, in the next 70 years, transfer this account to this user, to this address. So that could be an account managed by your son or your daughter or your wife or something, just programmatically. So nobody can just change it because they want to change it. It's there on the blockchain, immutable, it's law. And that makes it seamless. So you can just share wealth. You want to distribute a certain percentage of this to this so persons. So that's, for me, that brings some kind of revolution that we are not used to in the blockchain space. So I think these are like the benefits I would like to highlight. Just reiterate later on. So now we want to understand the EIP 4337. So this is the EIP, in Ethereum you propose. Everybody reads it. If it's what the community agree on, we build it and it becomes a thing. So this EIP was proposed, I think, 2-3 years ago. And Vitalik was part of the person who proposed this EIP. So this EIP introduced some new things that we don't know before. And the amazing stuff for this EIP, why it could just go so fast, is because it didn't change anything in the blockchain layer. That they didn't have to change the code that is running on all these computers. So when they do something like that, they call it a hard fork, where everybody uninstall what you have, install this new one, and you can continue with the network. So that is not a very easy process to do. It takes years and a lot of engineering to do. So, but seeing this does not need that, and we can still achieve the same purpose. It's novel. So we will dive into this a bit, and let's just try to understand why we are abstracting, how we abstract, and what's the difference when we abstract and when we don't abstract. So this is the EIP. So there's this website, EIPS. So all the EIPs is on this website. So this is the EIP for you to, if you want to go like a deep dive into account abstraction and how it works. So, but let's do like a shallow dive, not so deep. And I'll just use this instead. So we've talked about transactions, but now when you abstract when you abstract an account, you are no longer dealing with transactions. You're now dealing with what we call user operations. So we've talked about transactions life cycle. So we'll talk about user operation life cycle. So from that, now you can like get a glimpse of this is what happens when you push a transaction. This is how you push a transaction. This is how you sign a transaction to happen. So yeah. So this is how a user operation looks like. So it's very similar to what we saw earlier on. That's this big boy here. Well, there are some difference. All right. So the user operation have a sender. In the normal translation, it's called from. Then there's a nonce, which we have on the normal operation. We have something called an init code. We'll talk about that later. We have something called call data. So in this transaction, there's a field that is not here. Whenever you want to interact with a smart contract, you need to pass in, this is what I want to execute in this smart contract. This is the function I want to call in this smart contract. So all those things now are encoded into something called a field like this, but it's called data. So that field is not here because this transaction just wants to send money, not something fancy. So but in this case, it's not just called data, it's called call data. Call data. So the next thing is call gas limit. So how much gas do you think this your call is going to take? So that's what this is about. Verification gas limit. So remember when we said when you want to verify that a transaction, that we can just change our key scheme to something quantum proof. So you will also have to pay gas for that verification to happen. So something like maybe you want to do something like a binary pairing. It's a cryptographic kind of stuff. So all those pre-compiles, like all the functional fancy thing that happens, take gas also. So you can now limit, okay, if this transaction or this user operation is running, take this amount of gas when you are verifying. If it exceed, just I'm not doing again, pull me out. So that's what the verification gas limits does. So the pre-verification gas is before this verification starts, this is how much gas I want to expend. Should you expend this, I am not transacting again. And whenever a transaction reverts, maybe you want to send whatever you want to do does not happen. So maximum fee per gas, still the EIP stuff we talked about, maximum priority gas, the EIP stuff we talked about. So pay master and data. So this is remember when we say you don't need to have gas, but that's technically a lie. Before you can push any transaction on Ethereum, you need gas. So it's either you are paying or someone else is paying for you. So that is what the paymaster is here for. So the paymaster is just an entity that maybe I'm OpenSea and I don't want my users for the first 10 transactions to pay gas. I can just set up a paymaster that's going to check. Have you seen that pay gas before? It's up to 10 times that you have used my app, pay for their gas fee until it's up to 10 times. So that's what a paymaster does. Then the signature is that thing that this your account would sign to prove that yes, I authorized this thing to happen. So that is that's the user operation. This is how it looks like. So now let's talk about the user operation life cycle. So remember, transaction life cycle, we have the transaction we want to perform, we sign it, we push it to a blockchain member, blockchain node, the node processes it, my transaction is processed and state change happens. But in this case now, before it gets to the blockchain, there's going to be somebody in the middle. It's called a bundler. So this person is, give me all these user operations. I will pack everything together and send it to the blockchain on your behalf. So when I'm sending to the blockchain, this bundler is going to pay the gas for all these transactions, or let's call them user operations. Then these user operations, as they are ending, they'll check how much gas you spend to pay my transaction. They will pay you back. That's what's going to happen in this system. So that's kind of the only thing that changes in like the major transaction channel. So the first thing that will happen is maybe I want to swap on Uniswap. So maybe I want to swap on Uniswap. It doesn't die. So, and I've maybe I want to swap it for USD, or maybe it has gone so high and I feel it's going to go down a bit. And I want to swap my bag for USD. So when I click on that swap button, that can create a user operation, then my MetaMask is going to sign that user operation. So when I sign this, what then happens is that operation is then pushed to a bundler. So example of a bundler is Alchemy. So Alchemy also provides a bundler service. So the name of the bundler service is called Rundler. Quite a nice naming convention. So it's an open source it's an open source code. If you run it, you are running a bundler, and you can push transactions on behalf of this person's pushing user operation, and get some fees for doing that. So that is this. And if you just want to use it, they have an API called the Bundler API. So you just use the Bundler API, you send in some operations like push user operation. I've forgotten the name they called it, but something like that. And they will help you do that. But for easy integration, they have an SDK. Where did I drop that SDK? Yep. It's called Account Kit. So when you install this account kit, maybe from NPM, PNPM, Yarn, anyone you're comfortable using, you can then push sign user operations with that. So all this link will be dropped though later on Telegram. So that is that for what I'll call the transaction lifecycle. But we can't talk about the transaction lifecycle if we don't talk about how we talked about gas. Who is paying for this gas? How is this gas being paid? So that will introduce you to the paymaster. So the paymaster is that man in the middle that says, I'll pay on his behalf for performing this transaction. That's exactly what the paymaster does. So from the transaction lifecycle, when you sign this transaction, you push it to a bundler. Bundler sets the batch of user operation, push it to somewhere on the blockchain, and it's a smart contract called the entry point, just like the gateway for all user operations. So at the end of the operation, send the bundler the money they spent paying your fees, and also some extra token just to say thank you for pushing my transaction. So that's what the entry point first does. So the next thing is now the entry point is now validating that, okay, yes, this person that signed this user operation, that in this case, this signature here, is it actually correct from the code that you have in your account? Maybe it says if two signatures, the hash of two signatures is what I want to happen before my transaction goes through. That means two people must sign something before it happens. Then the entry point is going to verify that, yes, this actually happened before anything is going to happen, before the transaction is going to go through. So else it's just going to revert. So that's another role of the entry point. Then the last role of the entry point is, or the second to the last role is to execute that after verifying that yes, the signature is correct, then pays the bundler the amount of gas they expended and some other extra tokens. So that's it for the transaction lifecycle or the user operation lifecycle. So I think we've done a good let's say entry into EIP 4337. For just a much more deep dive, just read the blog, and there are some other links that will be on Telegram. So just before we go, we'll just pick I'll just explore the code base that implements this full EIP, show you things around it. So when you want to like read about it, you want to read the code and see how this works, you have an idea and you can easily explore it. So the code is posted at GitHub, of course. It's in Phoenix. Yep. So these are the guys that implemented the account abstraction. And I think some of the authors, the major authors, still wrote the code for this. So this is a hard hat project, kind of a foundry fanboy, but in hard hat, contract is stored in a folder called contracts. The tests, the folder called tests. I see source here. They have foundry. Okay, no, just TypeScript. So we'll go into the contracts folder. I will show you around, like I'm taking you through a new house, what's happening in each of these folders. So when you are reading through it, you have an idea. So the main stuff you're interested in, like if you want to build an account abstracted, let's call it, you want to build a smart contract account. The main thing you're interested in is in this core folder. So this is where the abstracts contract, those contracts you inherit, like in a class-based programming language, just like JavaScript, those classes you extend, those classes you inherit and add as your base class before you add your new functionalities. So these are where they are. So if you want to build an account like I did here, you just inherit this base account. So the interfaces, some utils functions, some libraries are inside that base contract. So the next is the paymaster, base paymaster. If you want to be the paymaster, you inherit this guy. So the entry points, so that's the reason why I've not opened the rest of this contract is I want to go through the entry point first. So the entry point is a smart contract that gets hit when this user operations is going to the blockchain. So I'll not go so much into details. I'll just show you around. So you just know what's happening. So yeah, so the entry point inherits few contracts, the stake manager. So if you don't have a paymaster, the question is now going to be, how would you pay for gas? So the entry point have this thing called a stake. So it's just that you deposit some money there on behalf of your smart contract account. Whenever they do anything, the entry point will go to that place and deducts the money for gas. But if you have a paymaster, you don't have to worry about that. The entry point will ask the paymaster, pay for this person, and the paymaster acknowledges, and transaction goes through. So that's what the stake manager does. So the nonce manager just simply holds the nonce, increments nonce. So this nonce that you see in this place, it comes from the entry point nonce manager. So it also implements reentrancy guard. So it's just a fancy way so you can't multi-call a function. Just a function replay that like withdrawing from a contract over and over and again without it deducting your balance. So I didn't research on this, so I want to just about what this is.
So, under that, on the SPDS that this is identifier, so that the common one is usually MIT, but it is.
Okay, let's say. Okay, this is another license. So this is, this is much more, let's say, sweet.
Secured.
Not secured. Anybody can just use this.
Okay.
Yeah.
Problem is that the reason why people started using this is so you heard of the Satoshi trials, where okay, right is which depends many people believe what is small. So the crypto community is divided into two. There is the 10% and the 90%. 90% is offset that you can access 60%. So you know, can't Satoshi. But everything points to the fact that he is or was part of the group, of the coalition, the CIA involved with the government, but he might change things, and he used an MIT license, and everyone fell for the MIT license. But then we were hearing from the trials. They said that that he was contacted by many governments when the Civil War happened, they were buying drugs with Bitcoin. That's how you do it. And because of that, he was contacted. And that's the reason why I came back and was like, okay, this is my stuff. You're not supposed to use it this way. And he's hinted in court a few days ago that there's a watermark on the Bitcoin part, which he wants to use at the end of the course, something like that. So, but it made people wiser because crypto has already been this open place, you know, just like there's not the first time crypto is doing open source software. This is the first time the major financial market is sitting with open source software. Usually people have open source software, but they keep all the money, they keep all the markets and all value, they have that. But crypto is the first time when people are making centralized applications all over the place, and it's been a culture. It's been an old culture for the cyberpunks. So now, which is coming back, or whatever he wants to call himself, he's saying that you can do this, you can do this, you can do that, which is why I think it's Sweden, you know. But it now makes people understand that you can use a more expressive license like this. This one gives you no rights whatsoever. You understand? It's let's build on we can build. MIT still gives you copyrights. You still have some copyright. So if I build a house and I'm like, okay, we'll call this house, let's call it salvation house, this house, and then as an architect, you build another house, but you maybe do it the other way around, and it's insulting to me. I can tell you, see, you can't call it Satoshi house. Look how you did. I'm personally offended. It's an MIT license, meaning that MIT license, let me just try and appreciate it. MIT license means that everybody here I can build a laptop like this, and everybody here can build a laptop. And it's cool. As long as I'm good. So I'll give you over. You don't have to come and ask me permission to work on this. But if you build something that I really don't like, probably you build a desktop computer and call it a laptop, call it a laptop. It's spoiling the brand. It's not what it is. So I can take it to court and say, because I have copyrights, you can't call this a laptop. You can't. Forget about explaining to me why it might look big. Is a futuristic laptop, but it's so big. You don't make this game, it's the vision. Nobody thought it like that. But with this license, I can't take it to court, because I take it to court, they will ask me, okay, explain why you say it's a laptop. And you're like, okay, that one is a zillion times more powerful than this one. And you look at that, you just do one technical explanation, but okay, we understand. So that's the difference.
Awesome. All right. So yeah, this guy is what they call supported interface. So it's in your contract, you can an external contract before doing interacting with your contract can ask you, do you support this kind of authorization? So this is very familiar in NFTs. So before you send NFTs to certain addresses, it will ask, can you receive this NFT? So it doesn't just get there and it's locked in there forever. So that's what this guy does. And it's also an EIP. If you looked earlier and I had to search this out, I've forgotten what it was. So that's for that. So the function that you should be interested in here is execute user operator, that's ops, and handle user ops, that's this one. So this one just taking a pack, like pressed in user operation from the bundler and execute all of them and make some certain checks, like this transaction paid the bundler the gas fee they expended. This transaction is valid, that the person who signed it should be the one to sign it. So all those checks is done inside this contract. And I think these are the two things you should just know about this contract, and you can read the rest much more later. So the next thing is I think that's it.
Because the viewpoint basically shows you who pays for what. Entry points
No, not completely. So the entry point is just like that gateway. You know, before, normally, if you want to send in your transaction, you just send it, just pick any node, send it to that node. And after some time, after consensus, your transaction is executed. But this time around, you're not sending it to a particular node. You're sending it to someone called a bundler who will take more than you have received from other persons, pack them together. Then he's not just going to call any network and say, this is a transaction. No, that will mean they will need to change the code in all these blockchains. So it's now going to a smart contract and say, this is an aggregated transaction. Help me execute it, validate it, and make sure they pay me my money. So that's what is the entry point just does. Just the gateway takes in user operation and does validation. So that's for the entry point. So let's just navigate other folders. So the interface is just hold all the interface for all these contracts. So if you want to interact with the contracts, just put in the interface and use it. So sample. So this is where sample stuff you could do with this EIP is implemented. So you can see a sample account. So that's an account, an abstract account implemented with the base account we saw earlier on. Just a sample implementation. This is how it looks like. Though they released a new version, I think a week ago, not up to a week ago, like 6 days ago, and it altered some of the function signature. So this is not so much a good resource if you want to. Yeah, a breaking chain. So a lot of function interface that the entry point is expecting, it kind of changed in this version. So, and the person who built this have not updated it. So it's open source. This one just is a contribution from someone else. So okay, this is how you implement a simple or a sample account. Yes. So it could even be a task for one of us. Just understand it, just make a PR so they update it to the later version. So that's sample account. There's also a sample factory. So yeah, that's my bad. So we didn't talk about the factory. So the factory is just an account, or not an account. The factory is just a smart contract that spins up this or that. So if a new user is coming and if you does not have an account, just create an account for this new user. So that's what the factory just does. It's a very, very simple code, just two functions. Get the address of a user or an account, then create a new account for this user. So that's what the factory just does. So the next token pay master. No, we don't need that. But this one just no, you pay your gas in Ethereum. But because now with smart contract account, it's now so programmable, you can now pay your gas in USDC. And they just automatically do the swap behind your back end. Yes, the stake manager.
So trying to understand that, okay, there is, because I hear it about, this is the first time I'm doing any major talk on manager.
Yeah.
We don't have any of this because so I hear that we are account abstraction, okay? You, as you said, you separate key from the account.
Yeah.
And the way most Ethereum accounts are in-game accounts, the OX of this and something,
True.
where the state can hold a lot.
And you would have to take custody.
Again.
Yeah. You might be done with it.
It's just gone. Again. I was asking that. Account.
I already know your question, just for you.
Okay, oh, okay, so I was asking, account abstraction, you just said is abstracting basically the account, separating the account from the key, the access to the account. Okay. And you know, the case of how early wallets are done, you need gas to be able to move and the signature to be able to move value from one account to something else. Yeah. So now that you have you separated the account from the key, how do you take value? So just like you say the stake master does, and the what you call it, like the token paymaster, the token paymaster. Yeah. How do they extract this tokens from whatever reserve it is on chain and transfer it? Having separated both from the account.
So basically it happens with signatures.
Okay.
So you know when you sign a message, with your signature, I can extract who signed this message. So now let me see if I can find the Zoom link quickly so I can share my screen. Don't seem to find it. All right. It's just meeting right now. Okay, so let me just share my screen again. Yeah, right. So why I want to share my screen so I can show you how we implemented it in this account. So this is a simple account we just implemented. Okay. Nice. So this is, so if you recall, we had that base account we saw earlier on. So we just inherit it and we can go on. So this is where the magic happens. Just this 5 to 6 lines of code. So in the user operation, remember there is a field called signature.
Yeah.
So in the user operation, what happens is the user operation, we get everything in the user operation, we hash it. So just to get like a fingerprint of this is what this user operation is authentically.
Yeah.
Should you alter anything in this, the hash is going to change. So we then sign that hash with our MetaMask. That's the key now. So we sign it with our MetaMask and we push it to the bundler and they do their magic. So what's not going to happen is from that signature, giving a signature and giving a message, we can extract the let's say the address or the public key that signed it. So we can do that with Ecover. So it's an Ethereum precompile. Just give me a signature, give me a message signed. I can give you who signed the message. So remember, our authentication here is now, we want the contract, this guy, he wants it that before anything happens, it should be the key that signed it. So on creation of this contract, so we have stored something we call DAO. Okay, that was my bad. So we have something called owner. So this owner is now the address of key. So anything that wants to happen in this contract, you must this signature that you are bringing must evaluate that this owner signs this. So that is the verification standpoint. So and whenever, remember the life cycle, if message is ready and this operation is ready, it moves to the bundler, then from the bundler, push it to the entry points, and the execution happens. So in the entry point, it's going to call a function called verify signature. And that is this function right here. So it then takes in the call data, that is our user operation. It takes in the hash of our user operation. Then recovers who signed it, that the signature and the hash, recover who signed it, and the address we get, that's now going to be that. Then compare, is this person the owner? If yes, return 0. If no, return this. Signature validation fails. So we don't want to revert because the entry point is the one calling this. So if we revert, it's going to stop all the things that the entry point is doing. So we just want 1 or 0, where ironically 0 is true and 1 is false. So that's how the validation happens.
Okay, so basically what you're saying is what they did is basically they gave the new signatures.
Yeah.
Because I thought there was one where we wanted to figure that out because it was too much far. They're capitalizing on the signatures to verify if the smart wallet, which is basically smart contract,
Yeah,
and move data
exactly.
and value. And then on the gas part, they ensure that, of course, the normal design was if you're moving something from your wallet, you are the one paying the gas.
Yes,
But
yes.
now anyone can pay the gas.
Yeah, anyone pay the gas.
So they just added this to
Yes. So one other thing, since we've opened this contract already, so let's just talk about this. So there's this problem that we have natively, though due to the way the blockchain was built. If I misplace my mnemonic, then my account is gone.
Yeah.
So but what if we could maybe propose a little bit of a solution, maybe not so much novel. We can just do something like a social recovery. So I have these 5 friends that I give them power. Should I lose my mnemonic? If 4 of you can come together, my account can permit me to change my key.
Once more to say.
Exactly. So if the 4 of them just call this function, perform social recovery, then it just imputes someone, that's my new key. That's what I just call new owner. So the owner will then become that new address, which I have the mnemonics for. So I just did this simple stuff, just you just elaborate that it's a smart contract, it's code. You can just do any fancy stuff you want in there. Just make sure this function is, of course, there, and this function is there. And that's it. So before we end the session, I just want us to look over the agenda again, then look over what we managed to achieve and the things that we still need to achieve. And again, why abstract accounts? Why should there be contract accounts? So we've been able to look into blockchain and transactions, transaction lifecycle. We've been able to look into user operation lifecycle, a little bit into EIP 433, and we've not been able to implement the wallet itself. I just showed you a little snippet. So the last thing I would have loved we do is discuss other creative explorations that this EIP makes possible, other creative things that can happen because our key is no longer bounded to accounts. So, and yeah, that's it. So lastly, A-Wallet brings an enhanced user experience. Private key management is a bit much more easier because you actually don't really need to push this transaction. Just hold it, sign it. You can now even make use of your hardware wallet much more efficiently. It's much more simplified transactions because you are not necessarily supposed to pay for gas. Someone else can pay for you. It brings you social recovery options and a little bit futuristic when it comes to changing cryptographic primitives, and it is more flexible. You can add some programmatic function inside to do something cool. Subscription, payroll, automated change of ownership, just anything you can think of, you can implement. And I think with that, that will bring me to the end of the session. So, yep, thank you very much. So, is there any questions for sign out? All right, I guess there's none. So I'll stop sharing now.
All right, guys, it's been an awesome time. So, is there any question from our online yours on YouTube. All right. If there's any question, please just drop it on the chat group on the Telegram, and that will be taken